Chapter 1, Section 2, Describing Matter. Matter is defined as anything that has mass and takes up space, and the term associated with anything that takes up space is volume. So let's talk about matter in terms of states of matter. Let's say that I have a solid. For example, we could have a sugar cube. We can look at it by placing it on the balance and see that it has a particular mass. And you can clearly see that it takes up space. If we talk in terms of a liquid, we could pour water into a glass. We can put that glass on a balance, and that would verify that it has a mass. And you can see that it takes up a certain volume of that glass. Let's also talk about gases. So gases, most of them we can't see visually. So how can I be sure that it really does have mass and takes up space? If we take a balloon, we could set the balloon on the balance, find its mass, inflate the balloon, put it back on the balance, and that would verify that it has mass. And you can clearly see that when the balloon has inflated, it has taken up a different amount of space. Let's talk about different ways to measure volume. Let's go back to that sugar cube. So that sugar cube takes up space, we can see that. But if I wanted to quantify that, I can measure the length, the width, and the height of that sugar cube and multiply them together, and this would give me the volume. We're going to come back to volume later on in this segment. We've talked about water. We know that water I can put into a glass and see that it has a certain amount of volume. But if I wanted to quantify that, I would need to use a graduated cylinder. Thirdly, let's talk about an item that's not a regular shape. So let's talk about pennies, for example. If I want to know the volume of a group of pennies, we're going to use a method called water displacement. So I'm going to take those pennies, put them into a graduated cylinder that already contains a predetermined amount of water, and I'm going to see by adding those pennies, the volume of water has increased. If I subtract that initial volume from that final volume, this would give me the volume of my pennies. Terms that are frequently used in a science class are mass and weight, and sometimes they are used incorrectly. So let's see if we can't clarify this. Mass is the measure of the amount of matter in an object. So, in other words, the amount of stuff an object contains. We've talked about one way to measure mass is to use a balance. Balances in our science classrooms typically measure in grams. But if I'm going to want to report my data to a group, we need to agree on what unit we're going to use. Okay. So the unit we use for mass is the kilogram. And we're going to talk about why this unit was chosen a little later on in this segment. And again, it's measured by using a balance. Weight is the measure of the gravitational pull on matter. Weight is its very own quantity, so it has a different unit called the Newton. And again, it's dependent upon gravity. So what does this mean? It means that if I'm here and I am able to travel to the moon, my mass would be exactly the same. I would have the same amount of kilograms. However, if I'm here on the Earth or if I'm on the moon, I'm going to have a different weight in newtons because the gravity is different. So I would weigh about 6 times more on Earth than I would weigh on the moon because the effect of gravity is less on the moon. Okay, so I mentioned the fact that if I was going to report my mass to a group, I would want to use the quantity or the unit of kilograms because this is something that we've all agreed that this is how we're going to report our data. Okay? And this came about in the 1960s that scientists from around the world decided that, okay, if we're going to communicate our data, we need to agree on units, and this is known as the International System of Units. So there are 7 base units: length, mass, time, temperature, amount of substance, electric current, and luminous intensity. Now in our science classroom, we're only, or particularly in our chemistry classroom, we're only going to be using 5 of these. Length is the quantity. The unit that we would report our data in would be meters. Mass we've already referred to as the kilogram. Time is recorded in seconds. The unit for temperature is Kelvin. So Kelvin is a temperature scale we're going to talk about later in this course in second semester when we talk about the gas laws. And we're going to talk about how the Kelvin scale relates to both Fahrenheit and Celsius. And then the last one is the amount of substance, which is probably the most important quantity in chemistry. It's referred to the unit as the mole. All right, let's think about my classroom. So my classroom, if I wanted to know its length, it seems obvious that I would probably use meters to measure the length of my classroom. But let's talk about something like my textbook or the distance from St. Louis to Chicago. These represent very small and very large numbers. So in the international system, we use prefixes, and these prefixes are listed in Table 3 on page 13 of your textbook. So you're responsible for knowing the prefixes and their relationship to the base unit. Now the base unit I'm showing you here is the meter, but we could replace meter with grams, or we could replace it with liters. So let's go back to my textbook. If I wanted to measure the length of my textbook, it's much smaller than a meter, so I would probably want to use units of centimeters. Again, let's mention the distance. So if I'm going from St. Louis to Chicago, I want to use a very large unit, so I would want to use the kilometer. A derived unit is a combination of SI units. So basically what we do here is we take the base units that we looked at a couple of slides ago, and we either multiply or divide them in order to come up with a derived unit. For example, we could look at the Pascal. So the Pascal is considered to be a derived unit because it's taken the unit kilograms and divided it by meters, and then multiplied it by seconds squared. So we can see that this involves the unit for mass, length, and time. Now the Pascal is actually a unit we're going to look at second semester again when we look at gases, because this is a unit of pressure. But one that we've talked about in this section is volume. So we've mentioned that one way to measure volume is to take the length times the width times the height. So if I would want to know the volume of my classroom, we know that the best unit to use would be the meter. So if I measured the length, the width, and the height and multiplied them together, I would get meters times meters times meters, which would give me units of cubic meters. Other derived units, so area is a derived unit. We've already mentioned volume. Density is a derived unit that we're actually going to look at in class in one of the models for this chapter. Molar mass and molar volume are also derived units. And again, notice the unit mole, which refers to the base unit, the amount of a substance.